We connected with Drive. Eli Jaedi, who has a PhD in signal processing and a bachelor's degree in electronic engineering. In this video, he talks about many ideas related to Lloyd Stovall's video on Maxwell, as well as the technology from Maxwell Chikumbutso. He discusses whether this technology actually works or not. Please listen and let me know what you think. Also, my email is mentioned in the description if you want to have any deep conversations. Let's begin by discussing Maxwell's invention. If you turn a MOSFET on and off, yes, it's true that you will see spikes appear. But first, let me tell you a little about myself. I'm an electronic engineer and have spent most of my life working on medical devices, including X-ray imaging, gamma imaging, fluorescent devices, and both wearable and implantable health equipment. I own 25 patents in these areas. Now that I'm retired and have learned some interesting things, I've decided to share my knowledge, both theory and hands-on experience, with younger generations. I teach solar energy to my students in Madagascar and also teach about sensors, conductivity, electrochemistry, and related topics in Vietnam and Peru. Now let's start with a few definitions. These are personal definitions I use, you're free to modify them as you like. A magnetic field created by a still magnet is a steady field that spreads out from the magnet's location. To draw energy from such a field, you need movement, like a coil moving. The change in magnetic flux in the coil creates electric energy, but this is only a conversion from motion, mechanical energy, to electrical energy, and there are losses along the way. Electromagnetic waves can be seen, just as a concept, as two fields, an electric field and a magnetic field, that move through the air or another material. An antenna is one method to create such waves, commonly used in radio transmission. When voltage is switched very fast, electromagnetic waves are created. These can interfere with other devices nearby. Many engineers work hard to reduce this kind of interference. Keep in mind that based on the pattern in which an antenna sends signals, the power level of the RF signal drops with the square of the distance from the source. That means if you transmit 1 kilowatt of RF energy, at a distance of 1 kilometer, only microwatts to milliwatts per square meter may be received. It's possible to catch this small energy, and you can find YouTube videos showing how it's done. However, this small energy is only enough to run tiny low-power devices like sensors. It won't be enough to power a full electric vehicle. A transformer is a device that modifies the form of input energy to produce a different output. It doesn't create energy, it has losses due to resistance in wires and heating in magnetic materials. You can feel heat if you touch a powerful transformer. Yes, transformers can increase voltage, like Tesla coils, or current, like those used in welding, but the power out is always lower than the power in, because of losses. Only superconductors, materials with zero resistance, have no loss. A DC power supply is supposed to maintain a stable voltage regardless of the load connected to it. But perfect DC sources don't exist, there's always some internal resistance. This is true even for batteries. You can test this internal resistance using tools made for that. For example, a fresh AA battery might have an internal resistance of 1 ohm. Because of this, output current is always limited. If you short circuit a battery, all the chemical energy turns into heat. This is how energy is changed from one form to another. Another form of DC supply is the output from a solar panel. When it's close to an open circuit condition, it behaves like a current source. If you look up the IV curve for a solar panel, either online or on YouTube, you'll see how it works. Just as a reminder, the efficiency of most solar panels is about 20%. So if sunlight delivers 1 kilowatt per square meter, you only get about 200 watts of electricity. Also, the kind of light produced by LEDs isn't ideal for solar panels. Solar panels are designed for sunlight, which has lots of infrared power. A MOSFET is a type of transistor that can act like a switch or a variable resistor, depending on how you control its gate pin. When the gate voltage is increased, for example, in an N-type MOSFET, the resistance between source and drain drops to very low levels, just tens of milliohms. Check the datasheet of a standard MOSFET to see this. These switches work very fast. When you switch a MOSFET on and off, you indeed get voltage spikes. Let me explain why. If you connect a coil or a capacitor to a MOSFET, a little energy from the power supply gets stored, either as an electric field in the capacitor or a magnetic field in the coil. When the MOSFET is turned off, that stored energy can't just vanish. It's released as high-speed voltage spikes that can damage nearby components. But remember, this is not free energy, it's just stored energy from the power source. Engineers constantly work on ways to handle this problem to make systems more reliable. Usually, this extra energy becomes heat, a loss in the system. For instance, DC to DC converters face this issue. These devices also lose some power in the process, but with clever designs, their efficiency can reach up to 95%. Still, output is always less than input. As for electromotive force, EMF, in electric motors, I prefer to call it back EMF. When you supply voltage to a motor, its rotor spins, and a voltage is generated in its coils. This voltage resists the supply voltage and limits the motor's speed. You can calculate this EMF using a motor model. A balance is formed between supply voltage and back EMF. A motor is simply a device to turn electric energy into mechanical energy, with some losses. A good motor can reach up to 92-95% efficiency. The rest of the energy becomes heat. Now, returning to Maxwell's idea, the claim that RF energy from radio stations is a valid power source doesn't hold up. RF energy in the air is too weak. The SAY Technology website claims that power comes from cosmic sources like the Sun, Moon, and Earth. You can check out their site. But here's the issue, the Moon doesn't produce RF waves, it only reflects sunlight. Earth's natural RF energy is difficult to measure and use, and although the Sun is powerful, its energy is mostly invisible and infrared light. Sometimes solar storms send a lot of RF energy, but those are rare and can even harm communications. My main concern is this: if using a MOSFET or other parts in a circuit, the output energy is always lower than what's put in. If Maxwell's system is really pulling kilowatts to run an electric car motor, then the energy must already exist and be gathered somehow. But if kilowatts of RF energy were flying through the air all the time, we would all feel it. Our bodies act like receivers too. Look at how strict the regulations are for RF exposure from cell phones and towers. If there really was that much energy in the air, we'd feel the heat, or worse, our cells and DNA could be damaged. Another issue. If RF waves are long, hundreds of meters, you'd need a huge antenna to collect energy from Earth. If the waves are short, then our bodies would absorb them, which could be harmful. Also, something odd on the SAY Tech site, the claimed maximum power for their electric vehicle is only 8 watts. That's extremely low compared to the kilowatts usually specified for electric vehicles by automakers. Let me also say this: you don't need any complicated equipment to test the Maxwell generator. You only need 2 multimeters and some high-power resistors. Use one multimeter to measure voltage across the generator. Use the other to measure the current going through the resistor, which is the load. This is the same test I do with my students in Madagascar. We start with one resistor, say, 1 ohm, and measure current and voltage. Then we change it to a different resistor, maybe 5 ohms, and repeat. The result is a typical IV curve, which is well known in solar panel tests. You can easily get these curves from sellers. To wrap up, I believe I've shared some information that may be useful in thinking about Maxwell's invention. It's your choice to decide whether the idea is believable or not. Thank you for listening.